Hi. Now imagine that you're a farmer and that you can track every seed in all of your fields. Not only its location, but the depth at which it was planted. Or that you're driving your car and your car tells you there's a speed trap ahead. And your car can see all the bumps in the road and automatically adjust so that you have a smooth ride. Or imagine that your clothes can monitor your body and tell when you're sick before you have any symptoms at all. All of these technologies are enabled by the Internet of Things. And we're going to dive into the Internet of Things and understand more what it's all about. My name's John Williams. I'm a Professor of Information Engineering at MIT. And in the year 2000, there was a person called Kevin Ashton, and he wanted to be able to track all the goods in supply chains. And he came to MIT and basically started the Auto ID lab and had the idea that we could put small electronic tags on every product in the world and then be able to track these products through the supply chains. What he wanted to know is, we call it the 4 Ws. He wanted to know where things were, what they were, why they were there, and when they were seen. So, using RFID technology, he invented little chips that could be placed on every packet. These are tiny little chips that will be able to give off an electronic signal when they're illuminated from a reader. So the reader can read these items from a distance of around 8 or 10 feet. And so you know exactly what are on the shelves in your warehouses and what are on the trucks. Now today, this technology has moved even further. So let me give you a quick overview of what underlies the technology. We've talked about the tags themselves, and today they're extremely cheap, less than a cent. And they can be applied very quickly as the goods are manufactured and are going down the supply chain. And what we need to be able to do is to find out the ID of the item, so this is what it is. We need then to be able to go to a database and look up exactly what that item is, how it's been packaged, and, for example, the size of the packaging so that we know how many we can get on each shelf in our store. So, key to this was basically the World Wide Web. So with the World Wide Web, we're able to hit machines from our browser, so from our cell phone, for example. We can type in a URL and that will send a message to a machine across the world. And not only can we address the machine, but we can ask the machine to do a certain task. We can basically fire a function on that machine. Now we do that using a protocol called HTTP. And that protocol has allowed us to talk to machines that are remote. So when we talk about distributed computing, we're basically talking about this technology that allows us to send messages from one machine to another. And not only can we send a message, we can include data in that message. And as I say, we can include commands. We can ask that, for example, a drone that happens to be flying in Hong Kong takes a photograph for us. Now, of course, we'll need the right permissions. The drone won't let anyone talk to it. It has security. But essentially, we can send a message from our browser and ask that drone to take an action. Take a picture, send us back the picture. So, distributed computing lies under IoT. Now, today, we have lots of the things that I'm talking about. The farmer can track the seeds that they're planting. The tractors have GPS systems on them, and as the seed is planted, the location is recorded in a database. When we're driving the car, today the cars have huge numbers of sensors, and they're creating gigabytes of data every hour. And that data tells the car manufacturer how that car is performing. The manufacturer knows all the components in the car. For example, a Ford Taurus has over 100,000 different variations. So the battery might be this type or might be produced by this producer, and they can know exactly what your car has in terms of all its components. And they can monitor these, and before the components fail, they can send you a message saying you need to go to the garage and have a tune-up because X needs replacing. So this predictive maintenance is huge. For example, aeroplane engines. GE and Rolls-Royce do this exactly with their engines. They know when components, how many hours of flying time they've had, and when they need to be replaced. We're seeing it also with sensors in clothing. Today we can wear Fitbits. There are devices being designed today that can tell whether you're hydrated or not. So all of these devices, we sometimes call them edge devices, and you'll hear the term edge computing. So if we have, for example, a device that may be an air conditioner, it's got enough power that it can do what we call edge computing, that it can monitor the sensor data that it's collecting about itself, and it can fire alerts if certain conditions are exceeded. So, for example, if the temperature goes above a certain level, then it knows it needs to send you an alert. And so today, our factories, the smart factories, are being monitored by these edge computing devices all the time. The alerts and the data are being collected centrally. So we call these brokers. So the data is sent to typically an MQTT broker that can handle this flow of data that's coming in, maybe multiple readings per second. And we call this streaming data. And we can analyze that streaming data as it's coming in and make decisions about whether that component is working properly or not. So when you go to your office, you can access all this data that IoT devices are collecting. In your corporation, it gives you insight into what's happening in your building. All the rooms, the temperature in the rooms are monitored, etc. I call this the central nervous system of the company, that the data tells the company how it's performing. It can then make predictions about what it needs to do in the future. We call this data-driven decision making. And that's the state that we reach today. The goal today for most companies is to leverage the data in real time and make decisions. So today we have data engineers that are constructing the nervous system of the company so that it can collect the data that it needs and act upon that data. You've seen in your home, you have your own edge devices. I have several Alexas around that start talking to me. I wouldn't be surprised when we'll wake up now because the trigger is usually the word Alexa. So we're having these edge devices, these IoT devices that produce all the data that enable other technologies to function. So today we have machine learning and AI that sit at the top of a pyramid, if you like. But underneath is the IoT layer that's producing all the data that we need. And then we have the data engineering, the data analysts, and the machine learning specialists. So all of these jobs in the corporation are there to allow the corporation to make smart decisions, to make data-driven decisions. So the vision of Kevin Ashton 20 years ago has now resulted in many, many technologies that rely on IoT. So take a look at home, take a look at the devices that you have, and you'll be seeing a lot more of and go home, take a look at the devices that you have, and I'm sure you'll be seeing a lot more of IoT in the future. My name is John Williams at MIT. Bye for now.